Hello everyone. Welcome to the FPV Electronics Repair Show, also known as Krhom Shop Live. I don't know how to speak. I hope everyone here is doing all right. And today I have a bit of a pre-planned program for you all. It comes from a request from one of our community members here in the Toulouse freestyle scene. And he's in the chat, and he's called Cam Casey, and he gave me a bunch of Whoop AIOs to have a look at, and because he's been a good sport in giving me a bunch of things without expecting anything in return, and he mostly or exclusively, I'm not sure, flies Whoops. I thought I'd have a go at those two boards today and see if we can get them fixed and put in the box. A few updates on the box itself. A bunch of things have gone away this weekend. We had a fairly intense series of sessions, and a bunch of people grabbed stuff from the box, so we don't have any ESC anymore. Still have a couple of flight controllers, an AIO, a VTX, and a camera. So we'll have to replenish the ESCs, so it's probably going to be focusing on ESCs next, but today we're looking into this first, and those are two BetaFPV Air AIOs, and those have a few very common failure modes. The main one is the ESC chip that does that's not this one actually, I'm pointing to the wrong thing. ESP chip is here, and it does the RF ELRS. That goes bad. It's soldered a bit weakly to the board, and when the board, it's a very, very thin board, so it tends to flex on crashes, and the solder joints come apart and break. So usually you just have to reflow it, and it makes the solder all nice and neat, and it just comes back to life. I know that from what Cam told me, one of them has that ELRS problem, the other one is a VTX problem, and one of them they both have or had a bunch of a bunch of hot glue holding the antennas on. So I started removing that before the live, and I realized a few of the capacitors next to the power amplifier came off. So I'm going to start fixing that and see if the VTX behaves well after that, but that could very well be the reason the VTX is dead on this one. I'm not sure the VTX is dead on this one, but I assume so. That would make sense. The two caps are probably fairly important where they are. So we'll fix that. And then we'll look into the other one. So that's one of the reasons you shouldn't use hot glue. Hot glue kind of, when it sets fairly hard, and on breaks it can dislodge components and tear off some capacitors. So use B7000 instead. It's more plasticky. It will do the same job of holding the antenna, but it won't rip components as easy. So yeah. So we have a bunch of people in the chat. Hi Neo, hi Pab, hi Mika, hi Cam, Danza as always, Pablo as often, and Gregory. I'm not sure I've seen you before, so welcome to the stream. I think it's the same board, yeah, the R65, R75 is the same board, it's the Air board. So yeah. I don't think those have any motor issues. Correct me if I'm wrong, Camcasey, but I think those, I won't necessarily need to test the motors if I know the motors work fine. So I can save some time and we can move on to other things. All right, but I think we're gonna just jump in and see if we can fix those capacitors. So let me show you under the microscope. I have to pull another. I was using this for the other lives, but those boards are so small they just don't fit well in this board holder, so I'm going to use this one instead. So let's go over to the microscope and I can show you. I think that's the one. Yeah, let me grab it in the drawers. Try to not damage it. They are thin boards, so I need to be careful to not damage it. damage them. I'll try to focus it well for you guys. Yeah, well, pretty good. So yeah, you can see here there's a capacitor missing, and here there's another one. So I have managed to salvage one of them in the piece of hot glue that it came with, but that's this one here. I'll measure it and I'll grab some new ones, because I see, so you can see on the board, those are the pads of the capacitor that remain soldered. So I'm gonna need to remove them, but it means the capacitor has some pads torn off. So I'd rather use a fresh capacitor instead. So yeah. So yeah, CamKC confirms that the motors worked well on both, so that's all good. And hey, Gregory says he just received his AIR75 today. Hopefully you enjoy it. It's a really, really good small bird. Let me clean up the board first. We'll start with that. It doesn't look that dirty when you look at it normally. As soon as you go into polarized light, you can see all the debris and everything. So, see if we can get rid of some of them. Some of them we won't be able to. It's like leftover hot glue, and you'll see it when I try to melt it. It's gonna look awful, but not much I can do about that. I'll try to remove as much as I could before the stream, but it's not that good. So yeah, way better now. Way better. Okay, so we'll start by removing the pads. I'll grab some thin tweezers and try to grab the pads if I can't just get them attached to my iron tip. Not even sure that iron tip will be small enough to not damage stuff. Let me put some solder on top, on the end of my tip, to maybe help grab the pad. Oh, maybe it's torn traces. So this one is taking, no, it's not torn traces. Okay, I think we're good. Let's see a bit better. Yeah, I think I'm just not seeing it well because the tip of my iron is too big. Let's grab something smaller. Let's go for this guy. I'll go as small as I can and put a bunch of flux actually, so we can hopefully see a bit better. We might zoom in as well. All right. Yeah, those boards are tiny, and we're going to be working on very, very tiny things today. So hopefully you guys can see as well as possible. There we go, there's something coming off. It's hard to see exactly. It's a bit... There we go, we have a nice thin pad. Oh, I managed to pull a component, I think. Yeah. That's... Is it? No, maybe it's still there, it's just... Yeah, I think it's still there, it's just under the blob. So we have a lifted trace here. So yeah, I'll try to put it back. I'll see if I can put it back with some tweezers. It is very, very small, so you'll see me shake a lot. But we have a trace here that might need fixing. We'll see if it's continuous to, so you can see the trace here. So this should be continuous to this. We'll check if it is. Well, probably not. Yeah, it broke completely. So we'll have to redo this, or we might just put the capacitor and then run a wire from, what was that? All right, so let me see. I'll use my iron. Now it's broken anyway. Yeah, those bolts are tiny. So we do have, oh no, it was just, the pad wasn't ripped, it was, good luck. So it was the capacitor pad, not the actual copper trace. So that's good, I managed to remove it and it's now nice. And I'm guessing this is going to be the pad as well. I think it's ground, so it's a bit sticky. Yeah, needs to be able to remove the pad. Yeah, it's the bolt's ground, so it's coming slowly. I don't want to run the risk of damaging the, yeah, there we go. The pad, the copper trace, I don't want to damage it. Yeah, it's not coming. And maybe I'll just do it with hot air if I can't get it. We can probably see, actually, let me see if I can. I can't really change much. We can see a shiny piece of metal sitting on top, and that's the torn off pad. I'm pushing it at the moment. I managed to move this, I think. No, it was always moved. But yeah, I'm trying to push it out of the way. Yeah, okay. If I'm not succeeding in removing that way, I'll do it with hot air. I'll clean up quickly. Yeah, despite the bolt being small, there is an issue with the ground pads sucking the heat out of my iron tip, because I'm using a very, very thin iron tip and it's struggling to heat up the whole thing well. Okay, let's clean that up. Yeah, so I was afraid I moved the component, but I didn't. Actually, I might be, maybe I have really managed to remove the thing, because I'm not seeing here. I'm not seeing, let's see if I can get it a bit more focused for you guys. It is right at the edge of the resolution my microscope can do, so it's not great. But yeah, you can see here there's a big, nice blob of solder in both sides, so it's probably fine to use this as is, even if there is a pad under it. I'll see if I can get something going for this guy. You can see it's also a ground. It has a big ground plane under it, so the whole zone here is ground. So you can see how the solder is kind of gooey. That's because it's a ground pad, so it's having issues heating it up well. Come on. Okay, I'll do it with hot air actually. I'll try to do it nice and clean. I'll come in with 360 and like 50% airflow and some very thin tweezers and see if I can move and lift the pad. Now, can I give myself a bit more light too? That would be great. Yeah. There we go. Nice. Now it's all good. Let's see if I can double check the other ones are done well as well. Let's do this other pad here. I'll try to not blow away any components. It's quite hard because I need to be able to anchor my left hand well, but then I have the hot air blowing on my hands and I'm burning myself. So. Yeah, I think I didn't remove the pad. It's good enough, I think. I won't insist. I don't want to run the risk damaging the traces. So I think we'll stick it. We'll stay on what we have for now, and let's make some nice shiny blobs of solder. Now the board's hot, so it should be easier with my iron to heat up the ground pad here. There we go, nice shiny blobs. Yeah, that's good enough. I'll leave the pad if it's there. It's not going anywhere, so it'll be fine. All right, so now we need to measure the capacitance. Oh, we have a bunch of activity in the chat. Let's see. Yeah, KMKC, the using hot glue specifically is not great because it's too rigid, but Beast 7000 is great. And it also comes off quite well when you need to do repairs, so it's good for me as well. The cleaning is done, Gregory, the cleaning is done with IPA, isopropyl alcohol or isopropanol. Yeah, I'm sorry, Gregory, I'm answering English. The streams are now in English, but I will read your things in French. I'm happy to read it in French, no problem. But the answers, unfortunately, are going to have to be in English. Do I use a hot plate? I will use a hot plate on some specific big ESCs, probably. I have one now. I haven't needed it before, but I will try to use it. Yeah. That's about, I haven't really had the need for it yet, so I'm not using it at the moment. Okay, let's see. I'll grab the small capacitor. Let's see if you can measure this. So this guy here, come on. Try to measure it. Let me put my meter in capacitor mode, and this meter is very, very slow to measure. So I'm gonna have to kind of try to squeeze it between my two probes and kind of leave it there for a while until you can read. I think I have it. Might not. Yeah, I need to find a way to squeeze it horizontally like this. I might have it. I think I have it. Let's try not to move until it measures. Come on, give me a value. Okay, it seems to be pretty stable at 6.8 microfarad. Okay, let's see on the other board if I can measure something similar. And we also need to measure the other one if we can. 6.8 microfarad. Can someone write that in the chat so we can remember? Please, if you don't mind. All good then, Gary. So let's see. Let's zoom out. No, not zoom out, but zoom back out. Ooh, that's dirty. Okay, let's clean that up. So that's the other board, and we'll see if we can get some readings on them. Thank you, Cam KC. My brush alcohol. And let's try to clean that up. Looks like I'm guessing some of it is just hot glue again. I did not clean this one yet. We just need it to be clean enough that we can read. I think it should be okay now. Let's see if we measure something similar. It doesn't mean much if we don't, because measuring in circuit isn't really a great way to, I mean, sometimes, especially capacitance, you can't really measure in circuit. It won't work, but we'll see. Let's see what we get. Let's wait for the value. Yeah, 7 microfarads, yeah, so that's similar. That's good. Let's see the other one, whether it's a similar value. Man, that meter is just so incredibly slow at measuring capacitance. I should pull out my other one, but the other one doesn't connect to my PC. It might be that you can't measure it in circuit though. I will, if I don't have a good reading. I don't want to go and pull out this one and measure it outside of the circuit, because those are really fiddly. So I'll first try with using twice the same. Like, it's very often that in those circuits they use the same capacitance whenever they can, so they don't have to pull out as many different components. That's called the BOM consolidation. And yeah, so I can kind of randomly try the same capacitance, and if I get issues, then I'll come up. Actually, you know what? I should remove it. It's not one of the smallest ones. I'm pretty confident I can remove it. So actually, I'll remove it and then we can measure it. So I'm kind of breaking possibly a good board, but I'm getting fairly confident in my ability to do that. So yeah, let's do that. Let's grab my best tweezers for this. My favorite ones are these ones. I'll come with the same to 350 temperature. I don't need to go super high in temperature for that board, because it's a small board, and I don't want to melt the connector either. Being a small board means it doesn't have a lot of heat capacity, so I don't need to heat very, very hard to get the components out. Okay, let's measure it and try to not send it to the moon. And then we'll put it back. Did I manage to rip the pads underneath? No, I did not. It's just some gray solder, I think. Not sure, but I think so. Oof, I almost sent it to the moon here. Alright, let's measure this guy, see if we get a similar value. Let's, actually, oh, it's so awful. I did get some special pliers things that you can use to measure, but the leads are so short I can't do it under the mic. Okay, so 4.5 microfarad this one. Alright, so good thing I checked, it's not the same value. Let's put it back on before I lose it. .5 and 6 or 7. The other one was 7 on the other circuit. Where was I? Here? Here. Up. There we go. Put down some flux. And we're putting it back here. Thank you, Gregory. That's very useful. So this one is the 4.5. I really like those tweezers because they don't really cross each other. Like they stay very stable even when I push hard on the handles. So I'm tacked in, I'm gonna come in with some more flux and reflow it. Tacked means I just melted the solder enough to attach at least one side of the capacitor. Now we should see it settle down when the ground side on the left melts. It's melting. There we go. Oh, it settled down a bit too hard here. As in, it blew away. Yay! Can I see it? Yes, I can see it. I found it. It's here. Let's see if I can not just tack it, but kind of get it into place completely. Oof. Yeah. Let me get in a better position. Kind of. Okay. So here so some days I will shake more than others, but remember this is very, very small, so I'm not shaking that much. So I'm just gonna put it in the orientation where I don't have the glue that kind of stops me. So there's a bit of glue on the top, and the glue is kind of stopping me. Would stop me putting it down on the pad. There you go. Here I have a good grab. Now I just need to find a way to heat it up without burning myself. I am kind of burning myself, but I'll suffer. So it's melted on the left and it's melted on the right. It's now melted on both sides. It's done. All right, so that's done. And I don't need to reflow it. So I probably should have lowered my airflow to kind of reflow it well, so it doesn't get thrown away. But it's always hard to judge. It also depends on the distance from my hand to like the tip of the hot air to the board and everything. So yeah, I should have lowered down to 30% or something. Yeah, oh, sorry, Pab, my fan is loud because I didn't enable the noise reduction. I have now, so sorry about that. It should be lower now. If I drop the capacitor, it's lost forever. That's true, well, except here it wasn't, but once I'd measure it, it's fine because I have spares, so that's all right. My flux is I'll show you actually. I really like that flux. It's the mechanic nanoflux. Very hard to read. Bad marketing on their part because it's hard to show, but mechanic is the brand and nanoflux is the flux. It doesn't smoke almost at all. It doesn't smell, and yeah, it's pretty good. It cleans well. So yeah. So this board is back together. Now we need to grab donors for our other board. So we'll have to go to my, I think that's an 0402 size. So for those who don't know, component size have a number, like they have a number to indicate the size, the physical size of those small SMD components. The smallest ones on the board are 0201. And that's the one size up, 0402. Those are resistors, so I have a big box of a bunch of value capacitors, and those go only to 4.7 microfarads. So I need to find the other one of capacitors. 201. I don't have a neat organized system yet. I need to sort a better organization system. That's resistors 42422. I hope I didn't miss and forget. Oh, 402 capacitors, that's the one, I think. Those cost like about €1 or €2 a piece, and you have a bunch of different sizes, a bunch of different capacities for each size. So I grabbed a bunch of them, so I have everything. So we are looking for, oh wait, those are the smallest ones, they're the picofarad ones. So it was the other one. We might have to do with smaller caps than it kind of requires, because that's the biggest I have. They only go to 4.7. So I guess we're gonna try using two 4.7s and see if it works. I don't have anything bigger. I don't have a donor, I don't think. Let me see. I'm pretty sure all the air boards I got, yeah, pretty sure all the air boards I've got are repaired successfully. So, yeah, I don't know why I'm looking. I know I don't have any. So I guess it's going to have to do with whatever the biggest size I have is. And I mean, usually capacitor, there is very few cases where capacitor size matters exactly. This might very well be one of them, because they have very different values. Why would we put two different values if you don't have to? So I kind of don't like this, but I mean, I don't really have a choice. I don't have donors, and we can't really go checking all the capacitors on all the boards I have to try to find something matching, especially since I don't have any other donor that has an onboard VTX, which could have the same value. So we'll try it with that, and we'll see whether we get something. And otherwise, I'll just keep a note, and I'll replace it later. I'll kind of order the new capacitors. It's good to know that I actually need other values than this. So we have this boy and that other boy. So I start with this guy up there, right in the middle. Let's clean it up first, and then we can apply some fresh unused flux. Right. And we want to put on some flux. I need a better flux syringe. Something thinner would be nice. And this is the right size, yes. I mean, is it the right size? Just confirming, but I'm pretty sure it is. This is the one I removed. Yeah, it's the right size. I could like possibly try to fit a bigger one where I would have the capacity, but I don't think it's a great idea. Right, let's do this. So I'll do it the same way. I'll hold it for the whole duration, wait for everything to melt, and it should be more than good enough. I don't have to reflow it. There we go. Easy. And let's grab another one. .72. So we have to move the board that way. Try to keep the board. I always align the board so I can get the most comfortable position from my for my hand. I don't know if that's the proper way to drop components from a pick and place reel, but it seems to be working fine for me, so I'm sticking to this method. I'll just drop them on the board and don't go away. I'll drop that on the board and kind of find their location afterwards. There we go. And I'm not 100% sure I'm melted here, so I'm going to lower my airflow and reflow it. I'm going to go for like 20% and reflow it, and not. I'm pretty sure it's done. It's good, but might as well be 100% sure. I want this to be shiny here under my tweezers. Shiny enough. It's not shiny, but it's connected. I'll leave it there. It's moving, so it's well melted. Yeah. All right. Those are not aligned, but that's not me. They were already not aligned correctly from the get-go, so don't blame me for those not being aligned correctly. I'm not going to fix it, though. It's too dangerous. It works. You can be, if you don't want to lose too much time, you can't be too picky. All right, so now we have at least Don't like how it's... Okay, I am going to be a bit picky though. I want that, the one I repaired to be nicely aligned instead of crooked like that. We'll come in a bit one more time. I'm allowed to be picky with my fixes. Oh, I'm going to regret this. I'm going to try to anchor my fingers better. There we go. I'm not going to regret this. That is zero regrets. 100% happy with that. Okay, good. We need flux that smells like popcorn or strawberries. I think you would get sick of it very soon. I'm happy with no smell. Thank you. Well, I mean, to each their own. Oh, Gregory, that's your job. You repair electronics. That's really good to have someone who knows what they're doing in chat, because I sure don't. I'm just self-taught, experimenting with stuff, and refusing to let electronics die in a drawer. That's all that I am. Oh, I got something new. I always get something new. I'll get things new all the time. But I got something to show you. I have this thing. That's a blower. And I'm going to use that to cool the boards because I get tired of blowing on them. So I'll do that now. So we can test them. And now, it's warm. It's cold-ish. It's cold enough to work. All right, so now we need to set up our testing scenario. We need to test stuff. So I'll need an antenna. Let me grab an antenna. Where's my antenna drawer? That's here. I've got something. This is an antenna. It's a big antenna, but it will work. I hope I didn't... I'm double checking that my jaws didn't move anything under the board, but they didn't this time. I'm quite wary of this because it has happened a few times now. I hit one side of the board and the jaws that clamp on the board force move some other components on the other side. All right, so I'll connect this to the PC. That should be enough to power the VTX. I'll plug in a camera. And we'll start diagnosing the two things we know might be wrong, which is VTX and ELRS. So we'll see first if we get some signal. I'll plug that in, I need a wider view so you can see the monitor. And I have no idea what race mode he flies in, so I'm gonna set that up. I need to grab the small BetaFPV board adapter thing. I have a bunch of them somewhere. Here's one. Huh. This one is an HD0 one. Fancy. They are the same pinning, so you can use whichever you prefer, or whichever you happen to find on your desk. All right. I mean, you can double check. Well, the bolt doesn't light up. That's not good. How did I break it? Did I break it? I'm saying they're the same. I'm pretty sure they're the same. So let's see if we give it juice directly. Give it the PC. Okay, so we get nothing here. Okay, that's not promising. That is not promising. So this will need further investigation. The HD0 is different. Well, Hopefully I didn't kill it, but I shouldn't have with 5 volts anyway. I'll try the BetaFPV one. That is good. I was pretty sure it was the same, but I will check if I have a million of them. I just need to find where they are. Where they are. Here, I can see one. Yeah, that's a genuine BetaFPV true connector. Let's see. Let's see if that works. Doesn't work. All right. I mean, we'll know. Let's see if the other one works. Now we can start with that one. I'll give it an antenna too, so I don't burn the VTX. And then we'll start investigating. That might be, and maybe I broke it. Maybe it was always broken. I didn't try it before starting because I started cleaning up the hot glue and then I saw the missing components. So I didn't really try plugging it in. Also, it might not be the one from KC, but I think it is because he used hot glue and I don't think other people do. That also has a blob of hot glue, black hot glue, or maybe it's something else. And this one also doesn't work. Huh. Interesting. Do they work? Is it like the USB-C connector that's broken or not? This one has a pigtail. We're going to give it some juice. So let's go for, I'll go for 4.2 volts, like a decently charged 1S LiPo. We'll give it a 2 amp break thing, a 2 amp protection, and let's see if it does light up. Pulls one, oh yeah, it lights up. It's just small under there. Might be that I didn't see the light because it's hidden behind the blob. Okay, but this lights up and pulls the required number of watts. I would say for that kind of board. Let's see if I plug it in USB with a BetaFPV one. If I can see the lights. So we're looking here for the lights. Oh yeah, this lights up. Maybe the other one did too. Does it also? No, this one doesn't have the... Right, so let's investigate the other one quickly, see if it can see. Wait. Oh yeah, the LEDs, they are here. I can show you on the microscope actually. Yeah, the LEDs are here, small LEDs. Right, so let's try again with the BetaFPV connector. And this one just does not light up. So we'll have to investigate what's happening with it. We'll see quickly if it's the connector or not. I'll solder a pigtail to it. And do I recommend you put some glue into the plug? Don't put glue in plugs. You can put some B7000 over the antenna to keep it held on onto the board, but yeah. Don't put glue inside the plug for sure. And I don't think you need to put glue around the plug, this plug itself. I'm seeing something though on this board that's interesting. Let me show you. We probably should do a full visual inspection first before we start poking at it more. But I can see, and let's zoom out a bit. Oh no, that's just hot glue, isn't it? Let me clear it up. I thought it might be something else. It is just hot glue. It's not broken. That's the STM chip. That's the brain of the operation. And usually when you get no response from USB, it's either that the USB connector is broken somewhere underneath, and that explains it, or that the MCU itself is dead. It can happen. But we'll see. We'll see. So I'll quickly put a pigtail on this boy, and we'll see. We'll see if we get some voltage. There is a leftover pigtail here. Let's see if I can remove it. Yeah, that's never gonna heat up the board. I need a bigger tip. Bigger tip. Let's see if I can heat up from here. It's not ideal, but should work eventually. Yeah. Let's try. Let's do it from the other side. I'll hang the board of the thing so I can grab it from the other side. I just want to try to remove that small bit of wire. I'm not in a good position. Let's see. I mean, at the end of the day, there's nothing. I don't really have to do it. If I try not to burn the ELRS antenna, and maybe I don't. Maybe it's not that important that I do remove it. Yeah, all right, we'll solder the pigtail on top. Let me grab a BT2 or equivalent pigtail. I do have a bunch of them somewhere. The question is where that somewhere is. Yeah, you know what? I'm gonna grab the first thing that comes, and that's gonna be an XT30. That's fine. I'm testing off a PSU anyway, so it doesn't really matter. I won't be plugging in a 2S battery inside of it anyway, anytime soon. And also, those are not the most beautiful textbook solders ever. They're just quick test solders, solder joint. I'll try to do it. I still need to be functional. That is not the right tip for the job. Oh, I can't see shit. Let me grab the right tip for the job. So I can actually see what I'm doing. If my tip doesn't refuse to work, which can sometimes happen. There you go. Probably would need some flux here, but good enough to test. Not very pretty, not my best job. Okay, so let's see what we get on the power meter and whether we get some activity from the LEDs. Let's first double check it's not shorted before I start injecting current into it. Let's do a continuity check on the pigtail. Yeah, it's not shorted. It would beep otherwise. Okay, let's give that a go. So still on 4.2 volts. We're looking to get LEDs light up here if it works. and I'm getting 2.7 watts. So it almost feels like the VTX is VTXing. Let's see on the side, actually. Do you get anything? But it feels like the MCU is not MCUing. Actually, I'm not sure exactly what's happening here because none of the LEDs light up. So something's dead somewhere in the board. I'll grab the thermal cam and we can have a quick look on the thermal cam. Let's turn that off for now. I don't empty the battery. Let's try the thermal cam. Yeah, totally. You should check for a short. Absolutely need to check for a short before I plug it in. But right now, there's no obvious short. It pulls 2.7 watts or 1.7 it was. So it's kind of the normal amount for a VTX, an analog VTX on those boards. So let's have a look at what we see heat up. So that's now turned on. Okay, so it seems to be on the other board. I don't think, yeah, the heat is coming from the other side. Okay, so that's this chip here and this thing here. Okay, I think that's one of the, in the region of the things I fixed. The first one, let's go have a look under the scope and I'll show you which chip it was. I think the first one is just the power, the power regulator, like the BEC, the buck boost converter, and that's expected to become hot when I'm having issues with the clamping the board. It's going to get hot always when you have a short down the chain. So that's this one, yeah. So that's the 3070. That's the back. That was getting hot, but it usually doesn't mean this chip is bad. Actually, I've yet to see one of them be bad, but something was heating up here, and maybe that we have a. Well, let's test those capacitors for shorts. We might have a shorted cap. It was where the damage happened, so we might have. Oh, yeah. Let's see if I can get a good contact. Keeps doing a short beep, which might be a short, or which might just be the capacitor. No, that's something shorted here. And I assume those are all in series. So one of them is shorted, I assume, because the heat was coming from there and not from the chip. I assume one of them is shorted. This is shorted too. And so being shorted here doesn't mean this one's bad. It could be any of those if they're in series. It's unclear whether they are part of the same series or not. So I'm gonna have to remove them. I'll remove all three and we'll see if we get the... Actually, might as well remove one, see if the short's gone, remove the next one, see if the short's gone, remove the next one. Let's remove the cam so I don't get it burned. Let's remove this so I don't get it burned. And yeah, there's diode. And let's see if this diode is dioding. Not sure I can actually get to the... Okay, let's go in diode mode. So from what I'm gathering, this should diode if I get in good count. Yeah. Okay. Oh, 0.02, that's not the right diode reading. The more I see it, the more it feels like the chip, the PA chip, might be shorted internally, but Yeah. Okay. Seeing that this is the easier thing to remove and put back, I'm going to remove the chip first and see if we get the short. And if I don't get if I still get the short, it's going to be easier to get to those anyway. So let's remove the PA. PA being the power amplifier. So that's the thing that amplifies the signal to get the power in the antenna. Let's remove this and we'll see. I'm gonna up the airflow back to like 60%. I'm keeping at 360. I think that's enough for those boards. And I'll remove it. Let's come on. Come in. There we go. I'll keep it. We'll remember where we see pin 1 is here, so that's going to be easy to reorient. So in case you don't know, to know the orientation of a chip on the board, usually that will mark the pin 1 on the board, and that's the white dot here. And on the component itself, there's also a marking. You can see a dot for pin 1, same location. That's a good way to know. All right, let's test for continuity. And we are looking to here, no beep or a beep between here and still beeping. So got something shorted and the PA might be good. So let's start removing them until, I mean, I could just do voltage injection and kind of try to narrow it down with the camera. Maybe that's might save me some time. So let's see if we can get a clearer picture on the thermal cam of what's shorted. I'm going to limit the the current limit I had was all right. I'm probably going to limit it a bit more. I'm going to limit to like half an amp for now, and we'll see if we get a clear picture of which one's hot. So we are looking around the PA. Let's see, let's move it so you guys can see. Oh, we can see which one it is. It is the first one of the row 3. Nice, saves me some time. I probably should have done that before removing the PA, but I don't really mind. That's easy to put back. I can't chase it from the milliamps total because they're all in parallel. So the reading is going to be the same for all of them. So I can't really. They are so close that the trace resistance won't be enough for me to tell the difference in milliohms. If they were farther away from each other, then yeah, you could try to figure out which one's the lowest resistance. But here, I don't think would be. I mean, my meter isn't even close to being accurate enough to say that. But let's remove this guy. He is the chosen one. Oh. I'm not shaking that much, am I? In real life. Oh, hello, my old friend. Time to move you back in place again. Oh, didn't wait for long enough. There we go. Let's see if our short is gone. Yeah, it looks like it is. I get a very short beep because of it's charging the capacitors. But yeah, I think we're good. All right. If they're all in parallel, I expect this guy doesn't matter a ton. So I should be able to go without replacing it for now until we can see that putting back the chip kind of gives us something, that the chip comes back alive. And if it does, I'll grab some capacitor, which is probably like a 10 nanofarads next to a board like this, and I'll put one back. Or maybe I won't, because I do run some risk. There is some risk involved in me trying to change something like this, which is me messing it up. So if it works, I might just leave it. I'll add a bit of leaded to all of this. Yeah, that tip is really bad. To kind of discard it and never use it again. I'll get some amount of leaded on there to make it easier to put back the chip. Let's clean it up. Probably don't need that much. Yeah, I need to get a better chisel tip that's of medium size, because this bent chisel isn't great for this work. For those parts, it's fine. It's for the... Oh, there we go. It's good enough. It's heated up enough. All right, so let's put back that PA. Same direction, same orientation. Let's try to not mess up all the... So I'm just going to tack it. I think it's tacked now. And I'll reflow. I don't want to run the risk of moving all the chips around it. So I'd rather kind of tack it in place first, reflow it nicely, and have a lesser chance of messing up all the chips around it. So for those who have been on my stream before, you might, I'm used to working on bigger boards, and I'll show you kind of a good example of that. That's like the kind of size I'm used to working at usually. So like the big chip and everything. So this is, I mean, I've done it before, but like this is very, very dense and packed in small components. So that's why I'm having, I mean, not trouble, but some level of unease. Okay, let's reflow this. There we go. Nicely seated in place. And double check that we don't have a short. Can actually check on the pads that, yeah, we don't. All good. Let's clean it up and see if it at least powers on USB. My sponge. All right. Let's use the blower on the board. Get it nice and cold, like cool enough. Yeah, that thing doesn't mess around. It's really good stuff. And it's cool to the touch. All right, let's see what we get on a USB. Let's let's do it the other way around so I can plug the USB in a decisive fashion. I'm never confident in plugging this side quickly. Right. Ah, there we go. Signs of life. Let's not let it power the antenna too far without power the VTX without an antenna for too long. So put on an antenna. But yeah, short is cleared. Let's see now if we get a signal. Where's my camera? Here. Here is the camera. That's the right way around. I love those boards because they have plug-in cameras, which is convenient for the bench. Let's bring back our friend the monitor. Let's pack that away. I do need to have it on. We are on race 8, but hopefully that's what cam is flying, but otherwise we'll change it. Let's remove this wire. There we go. Let's put it right. Do we get any signal? We do. We do get signal. Do we get good signal? It looks like we have like pretty decent signal. So yeah. Now I'm going to do a thing that you need to do on those boards is push on some chips, or kind of flex the board kind of works too. That's a good way to test if there's bad contacts in the boards. Yeah, that looks repaired to me. We'll test the ELRS. So we'll wait for it to go to Wi-Fi mode, and I'm gonna. So yeah, like I said, I'm not gonna put a capacitor there. There are 3 capacitors in parallel. You probably don't need all 3, and I don't want to run the risk of messing it up. It's very tight. I'd rather move on to the next one if that works. And so now we are in Wi-Fi mode. I'm gonna go to my Wi-Fi and put my bind phrase in, and I'll see if my radio binds to it and if we get movement in Betaflight. Right, sign into network. Let me push my bind phrase. I'm not going to show it to you. Otherwise, you come and steal all my drones. There we go. Now I'll grab my radio, which is somewhere. I did bring it. Yep. Let me zoom out a bit.
Welcome to HTX. Photo warning.
Let's reboot the board.
Telemetry connected.
Okay, so we have telemetry. Let's see if I didn't seem. Oh, I just burned myself on the VTX. Of course I did. Burned. Not, I didn't really burn myself. I surprised myself with a very strong burning sensation, but I didn't damage anything. Okay. Let's connect. And gyro works. And ELRS. What's receiver? Where's receiver here? Yep, I think we're all good. 1 for the box. All right. Yeah, so not hard, just meticulous tracking of what's wrong with a bunch of visual inspections. And thermal cam helps, but you don't need a thermal cam. Or actually, let's figure out if the HD0 is the same like I thought it was. If I can find where I put it. HD0, yeah. HD0, I'm pretty sure will work just fine. Yeah, it does. And I do see on my PC that it works. So that's good. All right, 1 down, 1 to go. That was a fun one. I'll get the components back, antenna back. I'll grab my pigtail back quickly. Actually, I'll do that off screen on my own time. No need to bother you with this. One thing I noticed though when I tested the other one, so as you remember, we plugged this one in when we were trying, and we saw the LEDs here. And let me remove the blob first so we can see them better. But I noticed no LED was coming from the ELRS chip. So that's probably the one that has an ELRS issue. So let's go to the microscope. And let's see if we can remove the blob. The blob. I'm guessing it's hot glue, but it could be, feels like hot glue. So I'll put my hot air on like 200 to soften the glue. Yeah, it is softening. Oh, nice and clean. So I don't know what that glue was doing here, what it was supposed to be holding together, but I was definitely hiding the LEDs. All right, so now we go back and we check that we get all the status LEDs. Let me kind of clean up the space a second. Let's tidy that up. I don't want to lose those and mix them up with something else. Try to keep it. I'm very, very bad at keeping stuff tidy. I have a very messy desk. The streams are really helping keeping my desk somewhat clean because I want to start all the streams with a decently tidy desk. But yeah, very much suck at keeping stuff tidy. Some of those tweezers can go back. All right. I mean, we'll go and make everything perfectly clean. Let's see if we get, actually, from USB, let's see if we get picture. Maybe we actually, the VTX works. So we'll check that. Give it a cam. There you go. And see what lights up. So yeah, we got those lights. We got immediate picture. We don't have an OSD, which might be something we look at after. Yeah, oh, that turned off. Oh, okay, that might be just the camera that's coming undone, or maybe it's the board itself. Oh, can you see? You'll see, actually. Let me zoom in for you. Oh, I'm getting USB. If I twist the board, I can get the green light to come on. So yeah, that's the issue with the ELRS I was talking about. I'm getting also a bunch of USB device not recognized on my PC, which means something's shorted somewhere. So we'll start by fixing the ESP chip by reflowing it. Should be as easy as that, and then we can go on to investigating the other issues, which might disappear once we have the chip sorted. So let's see. We might also reflow the OSD chip while we're at it, because we're getting OSD issues. So let's go to the scope. I'll show you what's what. So we have the ESP chip, which is recognizable from its ESP logo, and we have the ESC chip here. Let's clean up all of that first. So I'll do some cleanup first with the cotton, then I'll come and remove the blobs in the middle, then I'll heat it up a bit to get the flux more runny, and then we can finish cleaning it up. I'll try to... Okay, so let's clean up with the wick. I should have some wick here. Wick, wick, wick. There we go. Big wick. Oh, that must be a ground. Leftover bits of wire because someone was too lazy to desolder and cut the wires. I don't know who it could be. Or maybe the wire were torn off. That's also a possibility. Maybe no laziness was involved. I am quick to judge. All right, I'll give that a bit of heat on like 350 just to get the flux running a bit, and I'll soak up everything. You can see it become shiny fairly quickly. And then I come back with a brand fresh new foam, and I'll get all of that sorted and cleaned. If we're gonna reflow the components, well, I want them to be decently clean for the flux to come and do its job. So yeah, we're looking to reflow the top one and this one, and should be easy enough. Reflowing is something anyone can do if you have the hot air. I would say it's probably one of the repairing those boards when I have those issues is probably one of the first things you can try doing when you have a hot air station. And you can get a hot air station for very cheap, like about 50 euros on Amazon or something. Let's do this and I'll come in back with the flux there. 350, 50% airflow should be all that she needs. So here we'll wait for the solder to become melted. We'll tap the chip a bit to ensure that's nice and floating, and we'll be done. You can see it's not melted at the top yet. It's starting to melt. Not there yet. Not there yet. Yeah, there we go. That's moving now. Yeah, you can see it move. There we go. That's all that she needs. And now we'll do the other chip. Not cheap. Us French, we tend to very easily get the E and E sound wrong, like cheap and chip. It's not a distinction that's very normal for our language, so it's not unlikely we make a mistake like this. Like explaining to a French person who not a native, a very good speaker, that sheet and shit is not the same thing is hard. And that's taking forever to melt. It is a BGA chip, I think. Yeah, it is a BGA chip, so it means it has the balls underneath. I need to be very careful because I'm pretty sure all the components around it are melted at the moment. So I need to be careful not. There we go. I think we're getting there. There we go. There we go. I'll stop there. Yeah, all the small components around it have all their solder melted, so any hot air I blow directly at some of them might have blown them away. So, okay, we all melted. We all reflowed, and we'll see how it goes. I'm expecting the ELRS to be just back. That's what's happened for me every time in the past. So Hey, Mac Shaky. Happy to see you here. Oh, you wanted to hide the LEDs at night. I see why you put the black goo. That makes sense. So the whole point of them was to hide the LEDs. So that makes sense. But I couldn't see the LEDs. Stealth flying mode. You could just remove the LEDs, you know, it just takes a few seconds on hot air, right? Something that everybody wants to do. No, it was a good solution. Gorilla whooping. Okay, oh, Cam Casey is saying that this board didn't want to do the right beeps at the end of the startup sequence. And that kind of coherent with the fact that I saw it pull too many amps. It might be that the MCU is dead. We might be that the MCU just needs reflowing. So we'll see how it goes when it's cooled down. I plug it in and we'll investigate from there. But if that doesn't do anything, I'll reflow the main chip. Though the main chip might have just reflowed itself while I was doing the OSD chip. That's the one just under it. That's this one here, the STM chip. So maybe it will just work. Let's see. Let's see how it goes. Neo is asking, do you eat chips or chips? You can eat whichever you prefer. And let's clean the board up. Now it's had a few seconds to cool. Well, it's still very hot. You can see the alcohol is evaporating very quick. The glue is grabbing hold of my foam. Well, at least we know that board on top of the issue you're saying it had also had ELRS issues. That was immediately obvious. So I think it might have had both. All right, let's blow on this board to cool it off. Nice. Ah, that's so convenient. Loving it. All right, let's go overhead. So we're looking at first the ELRS thing. Second, I'll be looking and showing you after the ELRS is confirmed to work. So I'm going to twist the board a bit and see if I can make it break again if it does work. After this, we'll hop onto the PC view and see what we can tell from it being unstable. There we go, immediately blinking. And it doesn't seem to be going away when I twist the board. We are not seeing an image because I don't have the camera plugged in, but I'm getting, actually, no, I'm getting the USB not detected thing. So there is something wrong with the MCU or around the MCU. So there's a few things that are possible here. It could be that the MCU is damaged, but it could be that there's a few other possibilities. If something that's connected to the MCU is shorted, I've had that on a shorted gyro once, it will pull too many amps through the MCU, overheat it, and it will go into thermal shutdown. Yeah, and that would explain the no OSD as well, because the MCU is unbooting. Let's see quickly if we can get the MCU to shortly appear in Betaflight. So we have it there. I'll plug it in. Nope, not at all. Okay. Okay, not at all. All right, so let's have a quick look with the thermal cam. And if we see heat from the MCU, then I will reflow it. And if it doesn't fix it, it means the MCU is dead. I don't have any donor for this one. That's the small version of the G4, and I don't have any donor. They are quite expensive. You can cost about 12, something like that, 12 euros to get. Let's plug it in. Oh, so the voltage regulator is. Why is the diode? Huh. Why is the diode pulling that many amps? Okay, and the other side, I'm expecting the, yeah, that's the power amplifier that's supposed to get hot. That's the thing that, when we say the VTX is getting hot, it's not the VTX, it's the power amplifier. So, interesting. Let's go under the scope and check out that diode. I think it's a diode, maybe something else. Oh, it might be, it is a diode. Yeah, I can see it here. Let's go over the scope. Let's see if it's dioding as it should. I would expect this to be, I don't know what kind of diode it is. It kind of could be the TVS diode. And if it is the TVS diode, it's not supposed to get hot. So it might be kind of conducting a bit, and that means the voltage that reaches the MCU isn't high enough, and it doesn't get powered up well, though we did get some heat on the voltage regulator here. So let's investigate this diode. So first, we go to continuity mode. That's the beep mode, and we'll check. It shouldn't beep. Okay. Let's see if it is the TVS diode. So if it is, it should be connected between those two. And it doesn't look like it is. So I think that's just a protection diode from the USB that's getting hot because there's a lot of current that's being pulled here. And that means it's probably the MCU. That's what makes the most sense. I can actually check. Yeah, let me not. I got distracted by some goo here. If I want to reflow it, I'm gonna need to remove the goo. So let's remove the goo. I don't need to, but I'd rather have the goo removed before I attempt to reflow. Goo removal in progress. I don't get a good grip on those tweezers, but I tried all my tweezers, and at that size, getting a good grip on a small bit of glue is very, very hard. There we go. Okay, so yeah, so I'm gonna check whether this. So let's see which of the pins is 5 volts. Should be able to check actually continuity between this 5-volt pad here and there we go. So that's the exit of the diode, and here should match to one of the pins. There we go. That's the one. So that's the 5-volt pin. Makes sense that it's this side. Let's double check that the diode is doing its diode job correctly. So I'm going to put my red probe. Red probe on the left, black probe on the right to inject some current in that direction. And we should see, yeah, 1.6 voltage drop. So that's a Schottky diode that's doing its job. All right. So, yeah, so likely the MCU pulling too much. Let's reflow this boy. And hope that it does the trick. I'll try to, what I'm going to do is come in from bottom right to try to avoid melting the switch and the plug. Yeah, those boards being so thin does make them very fragile. I'll try to come in with a bit hotter temp to try to kind of rushed it. No, actually, I'll keep 350. It worked fine before. I was thinking trying to get the heat in fast and out fast, but yeah, it probably won't work that way. So let's reflow this. It's going to take a while. That should be good very soon. There we go. You can see the surface tension of the solder pulling it back. So yeah, that's reflowed. And yeah, if that doesn't work, I'll do a closer inspection with a thermal cam, but I'm not very hopeful. Let's clean that up. As always, we try to do it to keep the board clean as much as possible. Usually, if the MCU is not appearing in the in Betaflight without a LiPo or anything, it's either that there's a short somewhere downstream, and we'll check for that if that's the case, or the chip is dead. There's very little wiring or kind of things that can go wrong in between the USB and the MCU. So okay, all good. Let's go. And let's see. So here, basically, actually I can probably show you this view. I'm going to plug it in and we'll see if we get the overcurrent message from the PC or if we get anything else, but... Oh, we didn't get that before. Are we getting a... oh, wait. Let me plug an antenna before I burn it. Okay, that's promising. Before we would get the error fairly quickly, like maybe 50 seconds in, we'd get the error. Okay. So Betaflight STM electronics, that's good. Setup, that's good. I mean, this board has just, if that's fixed, that means it's all like reflow everything and it all works. Insane. So we're not getting any specific heat or anything. Let's plug in a camera and see if we get... No, Cam, I'm not a magician. I'm just thorough, and I'm starting to learn how stuff fails in some of those boards. It's just a matter of understanding how it works. Gregory, you're asking whether I managed to see where the source is. I'm not sure what you were talking about, so if you want to give me some precisions, yeah, I'll tell you. Oh, this one doesn't have an RX antenna either. Oh, I'll put an RX antenna. I'll put an RX antenna on it. It's actually a good thing to show how to do that. So I'll do that as well. I didn't notice, but yeah, it does indeed not have an antenna. But you can't really burn the RX without an antenna, even if it has telemetry. It outputs 10 milliwatts of telemetry, but that's not enough to burn the RX. So yeah, powering this up, see if we get an OSD. We do. And that seems to be solid. No, but All good. Yeah, I think we have this fixed if we can get the ELRS to bind and react, but I'm pretty confident. Without an antenna, it's still gonna work because the ELRS is dumbly good, stupid good. So
Welcome to HTX.
I'll do the test. I'll bind it to my quad. Well, you're saying that, Neo, that it's always the same, except when it isn't, because the other one had dead caps, you know, so they keep us on our toes. So waiting for this to go blinky. I'm keeping an eye on Betaflight on the side to make sure it doesn't disconnect or anything. But I'm connecting with my phone to the RX and doing the binding phrase. Okay, should be good enough. And see if we get, maybe I didn't save it correctly, that happens sometimes, but we'll see. Maybe it can't bind because of the lack of an antenna. I would expect it to still bind. Let's, I'll double check the binding phrase. Oh, it did bind. It just took forever because it doesn't have an antenna. But let's go to Betaflight, go to receiver, and it's not moving. Okay, I'm gonna put an antenna on it before we do anything else, just in case that's the problem. And then we'll see if it's just a misconfigured or whether we have an RX problem. If we do, we can always use an external RX. Oh, did you by any chance put... Oh, I think you put an external RX on this and the RX isn't connected. Okay, if you can confirm that. Yeah, yep. Did you actually disconnect it? Because you can remove solder. I'll show you actually. No, not microscope. There's some solder joints that I saw earlier, and I think they're meant to, yeah. So you didn't disconnect them, but you could. So as you can see here, there's TX3 and RX3 that are jumped. And those are just wires, they're 0 ohm resistors. And if you remove those, you free TX3 and RX3 to be used. Is that 3 or 2? It's hard to say. One of them. And yeah, so that's the antenna here. Well, let's put an antenna back on. So I'll try to remove this one if I can. So yeah, you can free the UART, but looks like he didn't free the UART. He just soldered an external RX and let the other one do its thing. It doesn't interfere much, so it's not really an issue. You don't get much interference from... There we go, nice hole. Now, the antenna, how does it work? Let me grab a piece of copper wire. And I'll grab specifically, so I have a bunch of copper wires, and they're all enameled copper wires. They are motor wires. I'll grab the thickest one I have, which I think is this one, which is close enough to an ELRS antenna size. It's a bit thinner. So I don't think I have one I can steal off a board. Maybe I do. Oh, I do. I can steal this one. Is it much thicker? Yeah, it's about the same. Let's do it fresh, and I'll show you how it works. So basically, you want your antenna you have the antenna, and you need it to be a quarter of the wavelength of your signal, and ELRS is on 2.4 gigahertz. And because I'm so good at math, I can tell you it's a 31.25 millimeters that you need, or maybe I just memorized it. So as long as you put a piece of copper that's 31.25 millimeters in length or close enough, then you'll have yourself an antenna. So I'll just do that. I'll just pull my calipers. Actually, what I'm going to do is cut it longer, solder it, and then cut it to the right length. So 31, yeah, so that's 40, something like that. I'll cut it here. If I can find my slide cutters. Oh, I think I need to catch up on chat a bit. Let me catch up on chat. Yeah, so CamKC is telling me it's misconfigured on UART4, so I need to reconfigure. That's why I wasn't getting any movement. That makes sense. Yeah, McShaky, that's what I was thinking. He might have disabled the RX, but I don't think he did in the end. But yeah, I'll go to the port setup, but after I do the antenna. Yeah, I agree. McShaky would still connect and not show movement. That's exactly what would happen. So here I have that wire. I'll move to the multimeter. Let me grab some tweezers I can grab the wire with and not lose it. So yeah, microscope. So I have this wire and I need to solder it here, but it has some enamel on it, so I can't do that. And to burn the enamel, the way I need to do it, the way I usually do it, is I put the wire somewhere and I heat it up with some solder until it becomes shiny and starts stinking like crazy. It stinks of motor. You can see the enamel boiling off actually. And oh, I just breathed it. That's the smell of dead motors. If you ever had a burnt motor, then you know the smell. Now it's there. I'll lodge it here and come in with some solder and solder it on. There we go. I even put on some flux. Smell bloody motor. Let's clean up my tip so I don't start accumulating too much. There we go. Let's clean it up. And now we cut it to length. So let me show you the results. You can see a nice solder job. And so, yeah, that explains why he was getting the motor beeps not all the way, because the MCU wasn't working. I think we have it pretty much fixed. I could test the motors, but that's something I probably won't. I have no good reason to assume the motors died, and I don't want to spend too much time on stream wasting your time with that, so I'll test it off screen. So now we want to do 31.2. There we go, good enough. And I'll cut that to the right length. Doesn't need to be extremely precise. It is ELRS after all. It's going to work regardless, because ELRS is stupid good. All right, let's see if we can get this working and set up to the right UART, which is probably 3 from what I understand. And hopefully now my radio should connect quite quickly too. Let's go to the screen share. Hopefully it's... Oh, my radios are not turned on.
Welcome to HTX. Telemetry connected.
My radio is now bound. And we have motion. This is now fixed. And we're not even 2 hours in, and we've already fixed 2 boards. I'm pretty confident in this one.
Still connected.
There's no reason it wouldn't be good. So, yeah. Nice one. I think I'll probably put on some motors and make sure it all works, but I won't do that now. It's not super interesting because I'm pretty confident it's going to work. So it's just watching me solder some motors and make them spin isn't amazing. So yeah, that's the box, and that's in the box. All right, now I very much need a drink, which is going to be some delicious water, and then we can move on to the next thing, which is probably... I have a few things. There's actually something I want to start with. So we have the box isn't full, Cam. It's not full yet. It still closes, so it's not full. But it's getting there. It's lacking in ESC. But first, what I want to do is investigate an ELRS receiver. So we have a young guy in the team who, being young, doesn't have a ton to spend on drones, who for some reason keeps burning up receivers. So I'm going to try to repair this and can get it back from the box. And from what he investigated, seems to be a dead capacitor, a shorted capacitor. So it's going to be a toss-up whether it's the cap that's bad or the ESP chip. So we'll have a look at that next. And yeah. And then I have a fairly big ESC job that needs to happen. So might look into that afterwards. Hopefully you're enjoying the 3-hour stream. For those who have missed the previous announcement, I'm stepping down from 2 streams a week to 1, so I can work on other projects because I've been slacking on making videos. I'm having too much fun with you guys. In exchange, I'm making the English stream, the only one stream I'm keeping, which is this one. I'm making 3 hours, so we're going all the way to the end of the up to midnight Europe time. Yeah, Neo. How are you? How is everyone doing? Let's put that under the scope and see what we can deduce from the small. So I think this board is quite interesting because it's only single phase, so everything's there, all laid out. And we can, man, those are like, I love how much stuff you can put on such a tiny board. To switch quick board tool. It's a very simple architecture. This is the brains, that's the MCU, ESP chip. This is the RF front end. That's the thing that does the modulation, demodulation of the signal. That's the power amplifier. It feeds into the antenna. And he's saying something's shorted here. So let's double check. Go to continuity mode. Obviously, as I always say, if you have any questions regarding repairs, electronics, FPV in general, feel free to ask in the chat. And if you put my name in the chat as well, at KRHOM, I'll see my name in orange and I won't miss your question. And obviously, if you're enjoying those repairs, feel please click the like button on the stream. It will increase the chances that other people get the stream recommended and I can get more people into repairing. All right, so that's BP mode. And that's shorted. That is shorted. And I think it's kind of discolored too. Like, I think the cap is kind of discolored, maybe. Let's see if I can focus on it a bit more. Well, it might be discolored. So it might be the cap that's dead. It's really hard to say before I remove it. And that's not shorted. That's not shorted. Oh, there's another shorted one here. Now, two shorted caps like that makes me think it's one of the chips. And you can try reflow them. Maybe the reflow will work here too, but I doubt it. Shorted two. So I do have, I think, a donor somewhere, but the donor might have the same issue. There's very few components that can go bad. So because it's shorted here, let's see if something's shorted on the main pads. No, nothing on the main pads. Yeah, so we start removing stuff, or we inject voltage. That's one of the two solutions. But my voltage injection isn't easy because I don't have a way to see the thermal cam under the scope. So voltage injection is going to be a pain. So I think I'm going to start removing the big chips. They're most likely to be bad. So I'll remove the STM chip first, and we'll see. They're easy to put back if I'm wrong anyway. So let's start with that. Let's grab my good tweezers again. Did I put them back? All right, let's go. It should be fairly quick because the board is so small, it will heat up very fast. It smells bad. Yeah, that reminds me I should turn on my my air pure. The thing I never remember is called my filtration. I'll turn it on. Not too loud, not too high, although it's too loud. But right, let's see. Let's see if the short is gone. Short isn't gone. And let's ensure we have a pin 1 indicator on those boards. We do the top left. That should correspond to top left on this. Yeah. Right. I mean, I guess we remove this guy. And we're happy if I need to put them back, we're happy because it means it is a shorted cap. And that's a good thing because it's easy to change a cap. They're cheap and plentiful. Right, let's check. Still shorted. Could be the 3.3 voltage reg, could be the cap. Let's keep removing stuff. And this one. Yep. I'm thinking it's probably the reg. But, so I'll remove that next. It's going to be a fun rebuilding job if we can fix it. Let's go to a view that's a bit more enjoyable. Yeah, I shouldn't try to remove it like that. See, those tweezers, interesting. We'll try some other tweezers because those and not thin enough to fit between the components here. And I think I have just the pair for that. These ones, yeah, these ones are perfect. See? I don't have a problem accumulating 20,000 different tweezers. They're useful. Okay, let's see if we get the still have the short. We do. Let's start removing caps. Maybe it was this cap all along. And I've done that just because I wanted to rebuild the whole board for fun. I mean, it's good practice. Nope, still shorted. This guy? Who else? They're all part of the short. What? What? I don't understand what it can be. And let's keep removing them. And voltage injection would make sense, but, you know, in for a penny. Remove them. I probably should keep track of which is which, actually. So, first one I removed, I put on the left. No. Yeah. What's this thing? And this an old board. Yeah, that's an old thing. Okay. Let's check. That is what one could say the brute force approach. Here's the brute force approach. You know what? What I'm going to do is check if the cap is shorted itself next to it, and if it's not, I'll replace it immediately so I don't run the risk of losing it. It's not shorted. Let's put it back. That way I don't run the risk of doing... and then I'll probably stop the madness and start doing some voltage injection. I was lazy, not wanting to do it, but I'll do it with the alcohol technique. That should work fine. I'm looking for my flux. Where's my flux? Where did I manage to put my flux? Oh well, I've got some other flux. I have no clue where I managed to send my flux. Okay, let's put it back on. Oh, I'm having issues. So these tweezers are great. They are great for... I see you pinged all over here. I'll grab the correct tweezers for the job. So these tweezers, they're nice and thin, but they don't have knurling inside of them, like some of the other ones I have that are better for this job because they have knurling inside of the jaws of the tweezers. They are better at keeping the cap orientated. So let me put this down and find my nanoflux. I'm bound to find it at some point. I'm very, very good at losing stuff that's just under my nose. But this Even has like a yellow cap. How did I manage to lose it? Sorry. Where did I put it? Oh, it fell. That's what happened. It fell. I broke my printed injection thingy. Okay, that's what happened. I'll finish with the other flux and I'll reprint my jig thing. All right, let's go back to this. Actually, I have solder on the bottom. That's our friend, the good old TBS flux from board from DFR, RIP DFR. Oh, well, that flew away. I was saying those tweezers don't fling stuff away. Well, I guess this one does. Let's see if I can find the damn thing. So many small bits and bobs on my map. Well, that's going to be an interesting search. I had faith in you, tweezers. I mean, otherwise we'll just grab any other cap. It's going to do fine. Yeah, I can't find anything. It might just have been sucked by the air thing. All right, let's keep finding. Let's do voltage injection and try to find our short, and then we'll put something back here at some point. Voltage injection. I need to cool the board and see how and see what side is what. So let's cool the board first. Should be fairly fast. Max Shaky is asking, how do you know if it's an SMD capacitor, diode, resistor, or just by looking at it? Brown is cap, black is a resistor. Diodes, they are black, but they're usually not black with the two shiny dots on the end that just, let's see if I can show you a diode here. Do we have a diode? And I also have a direction indicator. So no diode here. I can grab another board to show you a diode. I have a board here. This has a bunch of diodes, but I did remove some. That's a diode here in the middle. No, that's a transistor. I didn't see the other legs. That's a diode, but it's a bit of a weird diode because those tiny boards have tiny components, but that unmarked thing is a diode. It actually has a thing written on it. That's how you know the orientation. You have more diodes on this board. Transistors. That's a diode here in the middle. Another diode here. So that's a big diode, but usually, more commonly in a normal board, not an AIO, the diodes are way more recognizable. Let me find one. Maybe this board will have a diode. Yeah, that's a resistor, that's a zeros, that's a shunt resistor. That's those resistors that have very low values, used to read the current. No diode here. Well, that's a diode, but that's a light emitting diode, an LED. Nope, nope. Those are diodes. That's kind of the common, those are pretty big, but black with a white line telling you what orientation it is a diode. Some of the white components can be various things. There are not a lot of them, but it could be a fuse, it could be a filter, could be a small inductor, I think, though I'm not sure. Yeah. So what I'm going to do now is go in resistance mode, ohm mode, and diode, no, resistance mode, and try to measure. So ground on those boards is this bud. I'll try to measure the resistance to ground from those two pads, which I know are shorted, to figure out which one is ground and which one is the shorted component. So that's ground, right? It's hard to say. It's either this one or this one that's ground. It could be this one. I don't know if those pads are ground. Those pads should be ground. Yeah, so this one is ground. So here we should have a super low resistance on one end and a medium low. So yeah, 0.21, that's the resistance of my probes. That's ground. And this one hopefully should have a bit of a higher. No, it's purely ground. So they're all shorted to ground directly. So if I inject this on one of those, like possibly nothing's gonna heat up if I'm hitting the ground plane. So what I can do to try to know which one is the ground plane, actually maybe this one will have a better way of understanding. I was trying to look at the traces and try to guess, or I could try to heat it up with an iron and see if one sticks more than the other. Yeah, so yeah, I would say that's ground. That side is probably ground. It seems to heat up not as fast. Yeah, so I would say that's ground. So if I inject, I need to inject here. And let's see if we can see a different resistance, but I'm guessing we can't. So between ground and this, we should have extremely low. Yeah, 0.21. And this, from what I understand, this is going to be also very low. It is a bit more, so that explains it. All right, so if I inject here, and I have about an ohm, so if I inject 1 volt, I should get 1 amp, and about 1 watt, so I should light something up. So I'll try that. So what I'm going to do is use a pointed bit of my PSU, pointed tip on the PSU probe. I'm going to put my PSU to 1 volt and limit it to 1 amp. We'll see if I can get my crocodile clip here. That would be convenient not to have to manipulate the ground. I think we can do it. There we go. And now what I want to do is inject 5 volts with, actually should inject 3.3 volts here. Oh, well, I said I was injecting 1 volt. I'm injecting 1 volt here and see what lights up. But since I'm not going to use the thermal cap, I'm instead going to use a bunch of IPA and see what evaporates. So here we go. I have the PSU turned on. I'm going to dress everything in IPA. And we can see this is drying up. This chip, the one I didn't remove, is drying up quick. Can we see anywhere else that's drying up quick? Don't think so. Okay, so probably is that chip. I'm pulling about 1/3 of a watt, so not that much. Yeah, I can't see anything getting hot, so probably that chip. Let's remove it and see if we get rid of the shorts. So that's the way you can do it without a thermal cam. It's a nice trick to know. You have to know this technique because it's very useful. Right, let's remove that guy and see how we get on. You have the tweezer problem as well, Neo. Yeah, there's no one single tweezer that rules them all either. Okay, so power amplifier chip is out. And let's see if we have a short. Back to continuity mode. We don't. And here, we don't like that. Yeah, no, that's supposed to happen. Yeah. So the short is gone. So that's this chip. Let's rebuild the rest of the board. See that we are not having any issues. We should be able to actually see the lights power up and the blinking and everything without the power amplifier. So I think we should. So let's rebuild everything, and let's start with the hard bit, which is the tiny capacitor. This one is a bit bigger, so it shouldn't be too hard. Let's grab the correct tweezers. There we go. Okay. I think, let me check the other side, but I can touch it up with a... It's not soldered correctly, but I can do it with the iron. It's a big enough component that I can do it with the iron. It's the ground, so it's a bit... Oof. Come back. That makes me want to kind of reflow it. If it moves like this, I'm not confident it's well soldered on both sides, so let's reflow it. Try to come from above as much as I can, so I don't blow it off. There we go. Now we're good. Let's quickly do some tinning of the... I don't like that I can't really hold on to the board really well. Let's do some soldered, leaded solder tinning of all those pads. Let me turn on my air filtration. Yeah, I remember what it's called. Let's try not to put that much in the center. I'll clean up my chip and kind of grab some off. Actually, I might even do a tiny bit of wicking, just so that there's not... What's this? I don't know what that is, but get rid of it. Yeah, I think that's an okay amount of solder to have in the ground. I just don't want too much, then otherwise it lifts the chip and it makes it hard to get good contact with the rest of the chip or the legs. There we go. And now we put the chips back. Let's go from the medium. So we have a pin 1 indicator on the top here. So this needs to go this way. It's a pin 1 on the thing and pin 1 indicator here. be good. Oh no, yeah, I almost lied. Pin 1 is here with a bigger indicator here. That's just a confusing dot. That's probably not the... Okay, which one's pin 1 indicator? I think that's the one. But this dot is confusing me. That's probably not the third pin. If someone wants to go back in the stream and tell me I'm doing it wrong, please let me know. I'm gonna do it wrong, possibly. And then I'll come to check the chat, and if someone tells me that's not the right orientation, then I'll put it the other way. But should be it. Yeah. With that. Let's reflow this. Where's my Foxeer? Reflow it and place it in its right location. It's not a 9 here. There we go, it pulled itself correctly to the right location by surface tension. That doesn't look connected well. Let's see if I can fix it with the iron. Can my iron fit here? No, at this tip. Let's use the other tip. Let's use J-hook. Or knife tip. Knife tip is probably the right tool for the job, isn't it? If I can find my knife tip, it's here. Why is this? Why are those pins not connected properly? Why are they not taking the solder? Can I assume it's soldered because I had solder underneath or not? I'm not sure. Yeah, I don't have any flux here. Usually they're not capricious like this. Oh well, I can just redo it, remove it, and do it again, but let's clean up and we'll see. Cube, foam cube. I mean, I had a bunch of solder underneath, so I'm just gonna assume it's done. It's done correctly, even though it's not going up. And if I get issues, I'll know it's a suspect. But I'll do the other one, and we'll see. Let's do the USB. Oh, don't need that much. ESP. So now we have a. Do we have a clear pin 1 indicator? Is that this dot? Which makes me think it was the other dot. Yeah, I'm gonna have to go and check on the other on the stream whether I have them in the right orientation. Might be that we don't. Tacking it down, and then coming in with some more flux and reflowing it. That's a lot of flux. Oh shit. I don't think I moved any components. See, that's the same thing where it feels like it's. I might have. It might be that I have too much solder on the underneath, and it doesn't have good contact. Feels like that's the issue. I'm not confident in this. Let's see, let's inspect it. But I'm pretty not confident in the left one, so I'm gonna remove this one for sure. And I'll do it again with not as much solder in the middle, on the ground pad. I'm just not confident in this guy. There we go. And I also will double check the orientation. Let's clean this up and see if this looks decent from all sides. But if it doesn't, I'll do the same thing. It's good training anyway. Hi, Famtech. I'm happy to spend some time on an ELRS RX because I haven't done it before, though it's usually not worth spending too much time on it because they're so cheap. But it's interesting from a technical standpoint. Yeah, that doesn't look connected right. That just doesn't. That's not how it's supposed to look. If I look here, move. Let's go out to the maximum distance and see if I can get it in focus. Actually, that's not too bad. Actually, yeah, actually that's good. That's good enough. Yep. And then let's go for this side. Looks good. Okay, so maybe the ESP is connected one is good enough. Let's see the orientation of this chip though, because I have doubts between this being pin 1 or this being pin 1. It's a bit unclear. Also, I have that cap that needs replacing at some point. So what I'm going to do is first clean my tweezers because they're all sticky. Some kind of flux residue in my tweezers. And then I am going to go back and have a quick look at the stream. Give me a second and I'll confirm the orientation of the chip because I'm not sure. And that's the beauty of having a stream that you can go back to. and I can double check. And it was the right direction, so it's upside down, a text pointing bottom left. That was correct, but I still wanted to redo it anyway, because I think I had too much solder on the center pad. Seems to have kind of, so then I couldn't get good joint here. So I'll put back some leaded on those pads around, and we should get a good contact. So I was right in terms of direction. Okay. I'm not used to using a knife tip. I know some people in the repairs scene really like knife tips, so I'm kind of giving it a go. Okay. So we put back that chip. It was like this. It was indeed this way. Let's put it back. Okay, I'm gonna tack it in place here, and then I should be able to come back and just let it seat itself. We will want to settle correctly. There we go. From surface tension. Right, let's see if we can boot this up even without the cap and even without the PA. And if that happens, we'll be happy, and then we'll have to leave it here because I don't think I have a donor. I might have a donor PA, we'll check. Let's see if we can get it to work. But without a PA at all, PA being power amplifier, will not get very far. Alrighty then, let's give it a tiny bit. I'll need to clean that face too. I'll clean it up in a towel. Drowse it in IPA and clean it up in a paper towel. So now we need to connect some grounds. Let's put I had a XT30 somewhere. Oh, it's still attached to the thing I repaired. So let's put it quick. And I'll put an XT30 on this. So I'll just remove it from this board quickly. I'm doing it the way you shouldn't do it, which is completely freehand. So don't do it like this, kids. It's trying to rush the job. Yeah, I'm probably gonna regret trying to rush the job, so let's not rush the job. I have that tendency to want to rush stuff when it's not interesting, and then I end up losing more time than I save. So let's not do that. Okay. This can go back to the repaired box, and then we can come back to this. Okay. And okay. Let's see and see if we get a light. So let's go back to actual 5 volts on the PSU. I had it on 1 volt for the injection. And we have OCP. Well, I'll limit it to 1 amp, but shouldn't be much different. So here we're hoping to see something light up because we cleared the short. And we're not seeing that. Oh, forgot to put back the 3.3 voltage reg. Well, that won't work if it's not here. I guess that XT60 is gonna fall off probably when I put back the regulator, but we'll see. And yep, that's this guy here. We need to do it this way. Right, let's put up some flux. I did tool out everything on this board stupidly instead of doing voltage injection. That's a good lesson. Don't see what I was trying to say, trying to rush things, and I ends up taking more time. That's one of them. Let's do the other way around. And you guys not seeing it because it's the microscope view. I can probably show focus a bit better. Let's try not to fling it to the moon. And this one we should be able to get all in one go. Ah, I'm burning my hand. Let's see if I can not. Ah, shit. I'm burning my hand. My left hand is getting all the blowback from the hot air bouncing off the chip, so I'm gonna try to grab my tweezers from further away. And I guess some people use gloves, and I'm probably right. I don't, and I'm very much not enjoying burning myself. There we go. Oops! Hey, come back here. It's all leaded solder, so it's a bit more stays molten for a bit longer. Let's reflow it. Everything in this friend, the cap, and see. The cap's good. This guy's not good yet. Come on. Should be good soon. Maybe he's good. Probably good. He probably doesn't go further down. I'm gonna assume he does. We'll see quickly. What's that little chip, Mike Shaky? That's the 3.3 LDO regulator. So that makes 3.3 volt to power all the chips from the 5 volt you did it. I mean, I could just come in with some light tip, some flux, and kind of touch it, just in case. No, that doesn't. Yeah, I think it's nicely on there. I'll assume it's on there. We'll see quick anyway. Let's cool down the board. And then we'll try it. Oh, the boot button is dead. Long live the boot button. Hopefully it's not in a closed position. Yeah, well, we might have poked it, staying too long on the heat. I'm giving this a very little out of 5 chance of success, but we'll see. I don't know if the boot, I assume the boot is normally open and then we don't have a problem, but we'll see. On flight controllers, the boot is usually normally closed. And 0 watts. Yeah. So maybe it needs the power amplifier to do anything. Maybe I bought any of the chips or one of the chip moved. I think I'm going to call it on this because it's not very interesting. I mean, it's somewhat interesting, but it's just such a low value repair. I might spend some time on it on my own time, but I think I'm going to probably call it here, and we can see if we can fit some diagnostics of an actual important thing like an ESC at the end of the stream. I might look into this a bit more, but yeah, kind of try to do too many things at the same time. It's not great. So I broke my flux. Damn flux. My print. I'm gonna have to print that back. All right, yeah. So that's gonna be on the bench for now. And the thing I want to have a look at is an ESC that died yesterday on Saturday. A friend's ESC, 2020 board. It's a Foxeer. Foxeer, they are kind of pricey usually, so it's always enjoyable to save something that's supposed to be expensive. And it's expensive. Usually there's from what I've found, there's no real reason it's expensive. It doesn't really have anything special. It's all like just FETs and MCUs. It's all the same as always. But let's put in on the scope and see what we can see. I already see that there's a diode missing, and it's probably, yeah, there's a diode missing. I mean, is it just this, the issue? Could be. Could very well be that it's just this, because it's not a, is it a TVS diode? It might just be the TVS diode. We'll check quickly. If it's a TVS diode, it's fine. If it's missing, it doesn't really change anything. So we can test this by checking whether it's connected to plus and so I'm trying to touch the pads under it because TVS diodes are between the pads, and doesn't seem like it is. Okay, so it's not, so it's probably the reason it's not lighting up. So I saw this at the spot. It just doesn't do any motor beeps. So this could just be it, and that would explain. So that might be the TVS. That might explain why it's not powering up, because the voltage rail that's being powered by it is just not carrying any current across. So yeah, this should be safe to bridge just to test, because it would be a diode that protects the circuits and not anything more than that. Let's see if we can figure out the circuit actually. So we have 3 voltage regulators here, and that's all powering the MCU. I have no idea why that's 3 of them. And here we have the high voltage side. No TVS diode on this. So yeah, so there's nothing much we can get from this. So I'm guessing the output of this diode may be feeding into one of them, into the input of one of those rectifiers. There's a bunch of conformal coating on here. That makes it hard to test. Okay, there's nothing here, and this guy. It's hard to see. So I think that might need an overnight soak in IPA to remove the conformal coating and all the gunk. Okay, there's nothing. No input. I am in continuity mode. I'm guessing this. No, I can't find anything that even relates to this diode. Ah, there we go. Okay, so this relates to this. So this outputs to this diode, which I'm guessing it's like some kind of maybe a 5 volt or 10 volt reg to power the drivers, and then that feeds into, so that should feed into this somewhere, or not. No. Usually there's going to be like high voltage that comes in, gets stepped down. Oh, there we go. How did I get it? There we go. That makes sense. So yeah, I'm guessing that's 10 volt stepping down through this diode to this, which should going to be like 3.3. 3.3 powers the MCUs, 10 volts power the drivers, and this is, or maybe like, I don't know what this one is, but bridging this probably fixes it, or at least temporarily. So let's try that. Actually, what I'm going to do instead is check the voltage I get when I give this the juice. So I'm going to go back to my pigtail. I'm going to grab my pigtail and solder that small tiny XT30 to this board. So I can power it up and check the voltages so we know what we're doing. So we know what's what. Okay. So it always feels weird to see those massive shunt resistors being like encompassed, like being blobbed over. It's designed to be that way. It's just a weird design, in my opinion. Oh, that's going to take forever to heat up the ground pad with this puny little knife tip. I just don't need everything to become molten. I just need to bond well enough. Yeah, it's good enough for my test. It's just not the right tip for the job. Good enough. Right. So let's power it up and poke. So I'm gonna give it 4S. I still have the OCP, so it's gonna cut if it sees 2 or more amps. But I should see pretty much nothing here. Yeah, oh, 1 watt. Okay, so 1 watt is being pulled. Let's go to volt mode. Let's find a ground. I'll put my probe here, and here we should see some voltage. We don't. Down here. Oh, we have 16 volts here. Oh, bridging those is probably a very bad idea then. Was it? Did I mismeasure it and it was all along a TVS diode? Let's go back to continuity. Because I'm getting 16 volts here. Oh, it was continuous. I just needed to go through the crust. And here. Oh, right. You're right. So this is indeed the TVS diode spot. So it doesn't matter at all. So it can be left empty. So now we need to find what kind of voltages we get. I mean, could it be that this ESC works and the reason it wasn't powering up is because the pigtail was broken? Could have been, because it's pulling a normal amount of amps. I guess the first thing I should try is put a motor on it, see if we get beep. Because 1 amp is a very healthy current draw. 1 watt is a very healthy current draw. So Max Shaky is asking, does conformal coating make heat dissipation worse? And is it more likely to fail from conformal coating? In my experience, the FPV electronics doesn't fail from conformal coating. I think it's designed to some extent to coat stuff that's meant to get somewhat hot. It's usually a very thin layer, and I'm yet to see electronics that dies from being too hot, except when it's getting like hundreds and hundreds of degrees anyway. So maybe, nah, I wouldn't worry about it. I think it's more likely to fail due to being wet and shorted. So yeah, I'll pull out the test rig. I'll just shove 1 motor on it quickly and we can see if it does the beeps. Let's grab Omnifixo so we don't use a loose board. Let's randomly. So it's a 2020 ESC, so I can't really fit it in my on my test rig. So I'm gonna have to kind of cheat. And do it this way. Yeah, I'm gonna change to the more appropriate tip. Well, I'm not gonna do it now because I'm already in the middle of it, but I should really. Yeah, that's not the right tip for this job. Good enough to test. Are we getting them beeps? We are not, so it was indeed an issue. So we need to track down the rails. See what voltage we get, what voltage we don't. What we can check is also if we get heat anywhere specific. It could be that we have a short somewhere, a shorted cap. That's very likely. That's pulling down one of the regulators, and the heat should tell us which regulator is having trouble. So let's do that. It's going to be on the other side of the board. go. And we'll do thermal cam. Let's see if we can get at least a head start on this before the stream ends. So we're looking here, we have 3 regulators. Okay, we have a hot driver here. And here, the culprit might be this chip here, which is next to the hole. Okay, that's a resistor. Let's check. I would have expected that to be a cap, but it's a resistor. Let's check under the microscope. So supposedly the thing that heats up is this resistor. Let's see what its resistance is. The other thing that was getting hot is this driver chip, which might be shorted, might be pulling the so the resistor itself might not be, it's probably not faulty, because it's just heating up from from a lot of current going through it. Let's go to resistance mode. Let's see if we can go through the conformal coating. It might just be it might not even be a big resistor. Okay, 11 ohms. Is that normal? Maybe. 11 ohms would be dissipating a bunch of watts at 1 amp. Yeah, so I don't know if that's a normal value, but it could be. There's no reason I wouldn't trust it to be normal, but what I can check is whether it's shorted to ground, and that's not normal. So let's go for continuity mode. And I'm guessing one end is going to be connected to one of the outputs of this, here we go, of this LDO. And the other side should not be shorted to ground, but it probably is. It is. Yep. And I'm thinking this is probably what's causing it. So let's remove this and see if it clears the issue. I'd like to know, I guess the conformal coding makes it really hard to read the text on the chip. Kind of Foxeer, it's a Foxeer chip. If it is, I have donors for this. Let's see if removing it clears the short. Since it was heating up, I'm fairly confident it will. Yeah, it's a Foxeer chip. Let's clean it up so you can see better. Yeah, there's really nothing special about those premium ELCs. It's just the same chips. It's always the same chips. Foxeer, probably STM or AT32 and the same FETs. Right, let's remove this guy. Oh, here I'm gonna have to go ham max heat and close to max airflow, 80%. It's an ESC. They have a lot of copper, and it takes a while to heat up. So we go ham. Oh, and I'm gonna turn on my air filtration because it stinks. So sorry if my voice is distorted. It would be from the noise cancellation, noise reduction on my mic. Probably is distorted. Come on, diode. I managed to not lose the diode. I blew away a diode, but it's not lost. It's still here. Yeah. So I'll see if I can put that back now. But I don't know what direction. I'm gonna have a hard time figuring out what direction to solder it back on, because I'm gonna have to test it, because it's so sticky. Oh, the conformal coating, I can't see the text on it. So it's supposed to be continuous from left to right. Let's see if that's the case. Diode mode. And do we get a beep? Nope. I'll get a bit the other way. It's all gunk and goop. I don't, because it's all gunk and goo. See, the first way was good. I'm also on top of the board with a bunch of. I can't get it to read in any way. That's awful. That's awful. It's like I'm supposed to be able to see markings above it. Oh, there we go. Yeah, that's the right way. Okay, I've got some reading on the meter. So let's shove it back on that way. The gunk and the goo. There we go. All right, moment of truth. I'm gonna see what draw we get. I'm gonna put it down. So I probably should have, I'm kind of rushing this once again to kind of meet the end of the stream, but I should probably have checked, and I'm going to check quickly the shorted status of the FETs, just because the driver might have started to being hot, because I don't expect it would just get hot from a shorted FET. In my experience, it doesn't really do that, but I should probably be thorough and check. So I'm going continuity. I'm gonna test all FETs shorted for, if they're shorted for ground or for VBAT. It's just like probably something I should always do, regardless of the fault, and not try to rush it. Huh, it is shorted, but there is a dead FET. Right, this one, which is probably this one. So the 40-year-old chip might be good, for all we know. It's just the shorted FET. So to be continued. I'm gonna soak this in IPA and clean it up. It's very frustrating to work on that way. So yeah, I'm gonna do that overnight, and we'll pick it back up next week. Let's see, I'll check if I have some donor FETs as well. All right. We are getting to the end of the stream. Thank you very much for everyone who stayed around with me in the background, keeping them company, maybe, or for the whole 3 hours. It's absolutely fine if you want to keep this stream as ASMR or anything like that. I mean, it's not very ASMR, but I enjoy everyone watching and kind of keeping me company as well. That's the whole reason I do those streams. I want to do repairs and might as well share what I can with you all. Thank you very much, everyone. Remember to click like on the video if you enjoy it. We did manage to fix 2 cool wood boards, so that's that was pretty fun. And it was pretty successful, so that's really nice. Happy with that. And we'll probably pick up on that ESC next week for the same thing. I will get it fixed. Yeah, that's about it. It's going to be same time, same duration next week. Thank you again, everyone. Have a good evening, and I will see you next time. Bye.